got to give the people, the people, get the people what they want. Yo, I don't even know what that was. Sometimes you just got to do what you got to do. I need y'all to get this down. So I'm going to try to keep this video quick. More practice between simple and compound interest, all right? Get y'all set up. Simple interest. Get those bullet points. 1, it's linear, constant addition. 2, so that means it's going to be y equals mx plus b, where m is the growth rate, b is the initial value. All right? And then what's the big idea? You take your initial value and multiply it by the percentage that's given to find the amount added each day of the month or year. All right? So now you paused it, you wrote that down. Now go ahead and pause it and write this part down. So here's my example. I invested $950 in a bank account that pays me 4% simple interest. How much money will I have in 12 years? Pause it, get that written down. If you're on top of the game, try it real quick. Cool, you did it. So let's see. All right, it's $950. It says that I have to take my initial value, which is $950, and multiply it by the percentage. So I'm going to take $950 times, and here's the thing. I have to take 4% and change it into a decimal. 4% is 4 out of 100, because it's out of 100%. 4 divided by 100 is 0.04. So I need to take 950 times 0.04. Cool. I'm going to go ahead and calculate that right now. Let me see. 950 times 0.04. 950 times 0.04. And I get $38. That means every year the bank is going to pay me $38. So if I was going to make a table for this, boom, boom, boom. Let's go here. Year 0, I had $950. This first year, they paid me another $38, so that's $988. That's not supposed to say a 0. That's supposed to say a 1. In year 2, they're going to pay me another $38, right? Because they're giving me that 4%. So $988 plus another $38 is $1,026. And so on and so forth. So then I can write an equation, right? I could just keep doing this all the way up to, what did it say? It says, how much will I have in 12 years? But I don't want to do that. I don't want to keep doing this 12 times. So I'm going to write the equation. So my equation says y equals m, my growth rate, which is right here, 38, x, you can see up here, plus b, my initial value, which is right here, my initial value, 950. Y equals 38x plus 950. And now if I want to know how much I get in 12 years, I can just use this equation and plug a 12 in. Y equals 38, we're going to say x equals 12 plus 950. All right, I don't know what 38 times 12 is. 38 times 12 is 456 plus 950. And when I go ahead and calculate that, I get 1,406. So in 12 years, I gave them $950 to start, but if I let them hold it for 12 years, I get $1,406 back. Pretty good. Not so bad, not so bad, not so bad. So that is simple interest. That is exactly how it works. We worked on that in class today. You'll be having a test on it soon. Let's flip over. Let's talk about compound interest. Compound interest, I gave you some bullet points. You should pause it right now and write them down. It's exponential, which means it's repeated multiplication. So it's going to use this y equals a times b to the x, where a is the initial value, and B is your growth rate. And then I tell you, how do you find the growth rate? To find the growth rate, you change the percentage of interest into a decimal, and then you add a 1 to it. That's going to give you your growth rate. So hopefully you got all that down. Now you're going to pause and write this example down, right? So you have this to refer to in your notes. I borrowed $2,500 from the bank to buy some DJ equipment. So I'm borrowing money from the bank. If I borrow that money, they're going to let me hold on to it, but when I pay it back, I'm going to have to pay them back more money. I have to pay them money back in 6 years. They're charging me 8% compound interest. How much money will I have to ultimately pay the bank back in total after these 6 years? You paused it, you wrote that down. So now let's talk about it. So what does it say? We know this is exponential, so we know I need to use this idea of y equals a times b to the x. Said I got to find the growth rate, right? I already know y equals, I already know that my a, which is my initial value, is 2,500 times b to the x, something to the x. I just got to figure out what my growth rate is. So what does it tell me to do? It tells me here. To find the growth rate, change the percentage of interest into a decimal. So my percentage of interest is 8%, which is 8 out of 100%. And 8 divided by 100 is 0.08. All right, I just changed the percentage into a decimal. Check. Then add a 1 to it. Cool. 1.08. There is my growth rate, 1.08. I just built my equation. And now I can look back and say, well, how long do I have this money? Okay, it's 6 years, so x becomes a 6. So I can calculate this. Y equals 2,500 times 1.08 to the 6th power. So again, I'm going to start this and I'm going to say, what is 1.08 to the 6th power? I don't know. It is about 1.586 or 1.587. That was 1.08 to the 6th power. You should have got something pretty close to that. And now I got to take that times 2,500 because that's still there. So 1.587 times 2,500 is $3,967.50. And this is what y equals. So that's how much money. I only borrowed $2,500, but I pay back $3,967.50 if it takes me 6 years to pay them back at this interest rate. I got to give them more money back. That's why they let me borrow the money. Okay? So that is simple interest. That's compound interest. If I was looking at the table for that, right? Just so that we can keep it 100 right here and see everything and make sure we all on top of the game. We got x and y. I got my initial value at 2,500. Well, what's repeating now? It's not repeated addition. It's repeated multiplication of times 1.08 times 1.08 times 1.08. If I keep repeating that multiplication, that'll tell me 1, 2, 3, 4, 5 years, and so forth. Okay? So, these notes, super important. Hold on to them. They'll be really useful for the test that you all have coming up. That's our video for the day. Peace.